Hi everybody, today we discuss lipoproteins. A very basic concept of lipoproteins we'll discuss. First I'll tell you it is important to write an introduction of any question which is asked about lipoproteins. So you have to discuss this introductory part. Second, it is very important as a part of MCQ in your UG exam for biochemistry or your pre-PG entrance exams. Now, before we see what is lipoprotein, we need to know where is lipoprotein synthesized. So there are organs which will synthesize lipoprotein. First is intestine, second is liver, then we see intestine and liver together. Intestine and liver together. Okay, so these are the important organs. Intestine will help in the formation of chylomicron. The name of the chylomicron, it is a big name. The rest are all three alphabets. So chylomicron is also big in structure. Okay, so this is important to remember. Chylomicron, liver will form very low density lipoprotein, and intestine and liver will form together HDL, high density lipoprotein. This VLDL helps in the formation of LDL. So LDL is formed from VLDL. So now we have four lipoproteins: chylomicron, VLDL, LDL and HDL. Intestine forms the chylomicron, this is an MCQ. Liver forms the VLDL, the second MCQ. VLDL forms LDL, and intestine and liver will form high density lipoprotein. As I told that the chylomicron is big in structure, and as we go this way from chylomicron to HDL, the density increases. So it is lowest density and this becomes highest density. So the density is increasing. This is also one MCQ. So chylomicrons has low density, HDL has high density. So chylomicron has least density, HDL has highest density. And second, I had drawn a big structure because it is containing many alphabets. So it is largest size. The rest becomes smaller in sizes. Okay. So intestine produces chylomicron, which has least density and largest size. Liver produces VLDL in turn produces LDL. Intestine and liver produce HDL, and which has highest density. Now coming to what these lipoproteins actually do. As the name suggests that these are proteins which contain lipids. So these are carrier molecules which transport triacylglycerol and cholesterol to the place where it is required. So now if we see who's the bad lipoprotein, so this is a bad lipoprotein or bad cholesterol. It is called as bad cholesterol, and this is a good lipoprotein. The value must be high of this and the value must be low of this. So this is bad cholesterol, bad lipoprotein, and this is good lipoprotein or good cholesterol in layman language. Okay, so now coming to what does chylomicron do. Chylomicron transports triacylglycerol to the tissues. So it transports triacylglycerol to the tissues. It is produced from intestine and it transports triacylglycerol to the tissues. VLDL will also do that same thing. It will transport triacylglycerol to the tissues, but the difference is it transports endogenous triacylglycerol. That is the one which is formed in the body. It will transport that endogenous triacylglycerol to the tissues. So it transports endogenous triacylglycerol to the tissues. Now why LDL is called as a bad cholesterol? Because it transports cholesterol to the peripheral tissues. So this means that it is helping in transport and deposition of cholesterol to the peripheral tissues. So more the LDL, more cholesterol will be transported to the tissues. Therefore it will lead to atherosclerosis. Therefore if the level of LDL is high, it is a bad thing. Therefore it is called as a bad cholesterol because it may lead to atherosclerosis. Now what does HDL do? HDL transports cholesterol to liver for elimination. So it will also transport cholesterol, but it transports cholesterol to liver, and from there it is eliminated. Okay. So this is chylomicron. It will transport triacylglycerol to tissues. VLDL transports endogenous triglyceride to the tissues. LDL transports cholesterol to peripheral tissues, and HDL transports cholesterol to liver. So this is about the function. Now coming to the other point, that this is highest triacylglycerol. Chylomicrons is highest triacylglycerol. VLDL, we have no specific point for VLDL like that, but we have to remember that the highest triacylglycerol is present in chylomicrons. So because chylomicrons and HDL, they are reverse, that is, there is low density to high density. So this is highest triacylglycerol, this is lowest triacylglycerol. Okay, so this is lowest triacylglycerol. Now coming to the other important points, that is the apoproteins that are present. So the function is clear: triacylglycerol to the tissues, and it has the highest triacylglycerol, lowest density. The apoproteins now in chylomicron. Chylomicron, if we need to remember the apoproteins, we shall say that it contains all the apoproteins that are available. So chylomicron is apo A1, apo A2, apo A4. See, there is no apo D. Okay, so there is no D. So just do not confuse. So it has A, we have covered. It has B, it has B48. C, it has 1, 2, 3, and it has E. So it has almost all apoproteins. Apo A1, 2, 4, apo B48, apo C1, 2, 3, and apo E. Okay. VLDL, on the other hand, if we see that it will not be having any A. I am just telling you to remember so that you can remember, and your MCQ is not wrong. Okay, it is important in MCQ. All these apoproteins are important as a part of MCQs. So it has apo B100. It doesn't have A, it just has B100. It will have C1, it will have C1, C2 and C3. Okay, so it doesn't have A, it doesn't have E. Chylomicrons have all the apoproteins. VLDL has B100. Now it has got 100 marks, so it doesn't require A, it doesn't require E. Apo B100 and apo C1, C2 and C3. The bad cholesterol, which transports cholesterol to the peripheral tissue, it is bad. It doesn't require anybody in this world except for apo B100. So it requires only apo B100. So these two are pretty easy to learn. Apo B100, apo B100 C1 and C2, C3 in VLDL, apo B100 in LDL. Now coming to the high density, small size, good cholesterol, that is HDL, that is high density lipoprotein, which transports cholesterol to liver for elimination. It is almost at par with chylomicron in all the things, or you can say in contrast. Now we will see that it has how many apos. It has apo A1, apo A2, apo A4. So it has apo A1, apo A2, apo A4. The thing is that it will not have apo B. B is common till now. It will not have apo B. It will not have apo B. It will have apo C1, C2, C3, and it will have apo D and apo E. So now what is there? The apo D was not there in chylomicron, VLDL, LDL, but the apo B is not here in HDL, but there is an apo D and apo A1, 2, 4, C1, C2, C3 and D and E. So these apolipoproteins are important everywhere. Apo B and here also this is important. So you have to remember what is the function of lipoproteins, from where they are synthesized, how many apolipoproteins are there, and their physical properties. Now, why the chylomicron, one more important point that is asked is the electrophoretic mobility. If we have seen that there is plasma proteins, we had discussed in plasma proteins we had discussed that there is one alpha lipoprotein and there is one beta lipoprotein. Now I just want to make your attention drawn that it has ApoB100. It is just I want you to learn it, that is why I am giving you. So because it is only ApoB100, so beta lipoprotein was LDL, and because HDL has no no ApoB, so it is alpha lipoprotein. So this is the way that it is alpha, beta, and this is alpha lipoprotein, this is beta lipoprotein, and chylomicron, if I must say, it does not migrate. This chylomicron does not migrate electrophoretically. Does not migrate. So chylomicron does not migrate, and HDL will be seen in alpha band and LDL will be seen in beta band. Okay, LDL will be seen in beta band. So this is the alpha lipoproteins, and this is how they are electrophoretically they look like. Chylomicrons do not transport electrophoretically. This is a MCQ. Now one more important point is that ApoB48 and ApoB100, they both are same. This B48, B100, but there is a little bit of difference between 48 and 100, and why this difference occurs is due to RNA editing. This difference is due to RNA editing. Okay, this difference is due to RNA editing. Now we have done what is lipoproteins. How is lipoproteins formed? What are the functions of lipoproteins? Now the other important point that we are supposed to know before going to the metabolism of lipoprotein is that what is lipoprotein lipase, or rather who activates lipoprotein lipase. So lipoprotein lipase is present in adipose tissue, it is present in adipose tissue, it is present in cardiac and skeletal muscles, lactating mammary glands, but the most important out of this is that lipoprotein lipase is not present in adult liver. So this is also a question. So lipoprotein lipase is not present in adult liver. Adult liver doesn't have this enzyme. Now lipoprotein lipase is activated by phospholipids and ApoC1 and C2. ApoC1 and C2 activates lipoprotein lipase, and it is inhibited by ApoA1 and ApoA2 and C3. Okay, so ApoA2 and C3 inhibit the lipoprotein lipase, but it is activated by phospholipids and ApoC1 and C2. So these actually lipoproteins are more important as a part of MCQs, but when lipoprotein metabolism is asked, you have to initially give a small introduction of lipoproteins and you have to write all these points. Okay, so that's all for lipoproteins today. Thank you so much.